So today actually I'll start. Wait. Transfer function and Laplace transform. I have told you that you should go through once Laplace transformation and their conversions. That is important. So today we will start with transfer function. Okay. Visible now? My whiteboard is visible to everyone?
Yes, ma'am.
Okay.
Yes,
Yes,
ma'am.
Transfer function plays a very important role in control system. How? Because see, two things are very important in control system. One is transfer function and second is the mathematical modeling. If you know the both are vice versa. Suppose sometime what happened, we know the model and we have to derive the transfer function of that particular model. And second is we know the function, we know the transfer function, and with the help of that transfer function, we have to draw the mathematical model. So two things are happen here in a control system. So both things can be done. If we talk about transfer function, the proper definition of transfer function, I can say it is defined as the ratio of, okay, it's the ratio of Laplace transform, which is important, I told you, Laplace transform of output of any output, whatever we get from that particular modeling, to the Laplace transform of input. So this output is called actually response. Okay. So to the you can say Laplace transform of input, and here the input is the excitation. Okay, why? Because unless and until if you give a proper input, you will never get a response. Okay, so important is what input you are giving, and with respect to that, what output, what response we are getting. So here again, last line, what we have to write, and apart from all these two conditions, we have to assume that all the initial conditions to be zero. Okay, assuming all the initial conditions to be zero. Okay, so this is the proper definition of transfer function. So if we try to depict it in the form of a block diagram, so I can write RT, which is my input, definitely. Okay, input, and here you can get a block which is having a transfer function, so I can write it GT, and output you can take CT. Okay, so this is a system in time domain. So now comes two domain, one is time domain, one is S domain. So S domain is the Laplace domain, so I can write this is actually the system in time domain. Okay, so now you will tell, ma'am, how can we write this particular system in Laplace domain? Just you have to replace the time, that is T, with S. So I'm telling that we have two domains. One is time domain, one is S domain. That is the Laplace domain. I'm going to the next page. Okay, so now if I write the system in S domain or in Laplace domain, that will be somehow like this. Clear? Like this. So this is the system in Laplace domain, or you can say, or in short form we say it as S domain. So I think this much is clear how the domain we are doing. Now here, if GS is the transfer function of the system, this is the transfer function of the system. I can write in short form TF. So how can I express GS according to the definition of the transfer function? Where is
CS by RS.
Yes, Laplace transform of the output. Okay, and next is Laplace transform of the input, keeping all the initial conditions to be zero. So whenever you are writing transfer function, make sure that you write also this condition, that all the initial conditions initial conditions are assumed to be 0. Okay, otherwise it is not valid. Okay, so yes, whatever you have told, it's right. CS upon RS, this is my final equation. So same thing will be applicable for here also. Initial condition to be 0. So this is actually, if you are given any mathematical model and if you are supposed to find out the transfer function of that particular model, so you are asked to actually find out CS upon RS. ये दिमाग में रखना है, ठीक है? Okay. Next, we will talk about the properties of transfer function. What are the properties? See, first property, let me tell you very minutely, listen to it. First is transfer function of a system is the Laplace transform of its impulse response. Okay. Impulse response. The word is impulse. The word is impulse response. Okay. Impulse response under the same condition, what? 0 initial conditions. Second is replacing S variable with linear operation, which I told you also during mathematical modeling. At some portion, what we had done, we have replaced S with what? With d upon dt, right? I think you remember, if you just follow my previous videos, I have told you that this is the way how we are replacing the linear operation, where capital D is there, we are replacing it with d upon dt. So then this is the way how we can obtain the differential equation of the system. Okay. Third is no inferences can be drawn about the physical structure of the system from the transfer function. So any mathematical modeling, what you are doing with the help of any transfer function, you can't derive any consequence or inference about the physical structure of that particular model. Okay. So next we will move on to our next connected topic with transfer function, that is poles and zeros. Very important, because when we will do big problems, these two terms are important, poles and zeros of TF. Okay, that is transfer function. Now poles and zeros, I told you that transfer function here you can write, that is GS is equal to what? CS upon RS. Clear? This is the fact. Assuming the 0 initial conditions, 0 initial condition. Okay. Now, we have to assume an equation. Let's say, I'm writing here, let GS is equal to, I'm writing here, okay. GS is equal to S minus B1, S minus B2, S minus B3, okay, S minus Bm. Clear? And another is S minus A1, S minus A2, S minus A3, S minus A8. Let us assume this equation, which we actually need to find out the zeros and poles. Okay. Now, zeros, first of all, you need to know what are zero, what are pole. The proper definition is there. Now, zero of a transfer function is defined as the value of S for which the magnitude of the transfer function becomes 0. Okay, so let me repeat again. Zeros of a transfer function, I'm talking about 0. Okay, so zeros, it's actually zeros. Zeros of a transfer function are defined as a value of S for which the magnitude of the transfer function becomes 0. So if zeros of transfer function are repeated, then they are termed as multiple zero. If not, then they are called simple zeros. So basically we refer the term actually zeros. This is the basically very familiar term. So let's now come to the poles. What about the poles? Poles of transfer function. Now, poles of transfer function are defined as the value of S for which the magnitude of the transfer function becomes infinity. So definitions are more or less same. Only the difference is that in case of zeros, the magnitude that becomes 0. Okay. And here the magnitude that becomes what? Infinity. Right. So this is the basic difference between the two definitions. Otherwise, they are similar. So here also, if the poles are repeated, then they are termed as multiple poles. If not, they are termed as simple poles. Clear? So characteristic equation, if I try to do one of them. So let me give you example of it. This is one of the characteristic equation I'm writing. So here what happened, I'll draw a circuit, okay? And denominator polynomial that I will tell you. So let me draw the circuit first. Okay, so this is my circuit. This is the positive, negative. This is my output basically. And this will be the path of the flow of current. Okay. Now, the denominator polynomial in terms of S of transfer function is known as characteristic polynomial. So you need to learn also what is characteristic polynomial. So what I told the definition, I just now told that the denominator polynomial in terms of S means Laplace domain, of a transfer function is known as characteristic polynomial. And if this polynomial is equated to 0, then we can obtain a characteristic equation. Okay. Now, in this particular circuit, what I have shown you, you first apply KVL. Can you apply KVL in this circuit? Apply KVL and tell me the equation. Apply KVL, tell me the equation. KVL, KCL, you are much aware of those things, right? You have learned in network theory, in circuit theory. So apply KVL and then tell me the value. Equation actually. Can you do it after applying KVL? Hello? Am I audible to everyone?
Yes, ma'am. Yes.
And tell me the equation, please. First equation, you just tell me for VIT. Okay, you will be having two equations from here if we apply KVL. One is for the input voltage, one is for the output voltage. So first of all, let me do it. For VIT, that is the input voltage, what I'm getting, that is will be RIT. I'm writing it, you just match it, whether it's correct or not. Then it will be with inductor, that is obviously DIT upon DT. Okay. And the last one is with the capacitor. So this is all mine. It will be again like this. Okay. So just follow my previous last lecture, lecture 4. You will get some similarity with them. With a long time gap happened. So you might have some problem in understanding. So later on, you will just get accustomed to it. Acha, V0 का क्या होगा? V0 will be only capacitor. Okay. This will be I T dt. So these are the two equations actually we are getting from here. This is actually characteristic equations or characteristic polynomial equation, which we can say. Now, what your job is to take Laplace. Okay, because I told you in control system, whatever things we are doing in T domain, now this equation is in T domain. I hope you understood. This equation is in T domain. Now, what is our job? Now, our job is to convert T domain into S domain. Okay, so that what we will do now. So now we will take Laplace. So I'm writing here taking Laplace. So if I take Laplace, then what will be my equation? You have to replace the T with S, right? Because we are doing it in S domain, as I told you, right? So here VIS is equal to RIS, okay, plus SLIS plus IS by SC. Okay, so you just match it. Whether, see, we have just replaced the T with S, and that's all. Okay, that we have done here. This is the way how we are writing the T domain equation into S domain. And for V0, I'm going to the next page. For V0, S I'm writing, that will be simply I S by SC. Okay, so this is my another equation in terms of Laplace. Now, you have to write the transfer function in form of Laplace because you know the Laplace equations. So transfer function that will be equal to GS, that is equal to V0S upon VIS. Clear? That will be equal to like this, IS, okay, and then R plus SL plus 1 upon SC IS. This will be my, because I have just taken the V0S equation and the VIS equation and doing like this. Okay, so from here you can write 1 upon SC R plus SL plus 1 upon SC like this. Okay, and next if we solve the equation, we will be getting here 1 by SCR plus S square LC plus 1. I think this is clear to you all. If you solve this equation, you will get this transfer function. So this is the transfer function of this particular model. Okay. Done. I hope this much is clear to everyone. Is it clear?
Yes, ma'am.
Okay. Now, there are two theorems. Okay. Two theorems. One is called initial value theorem. Second is final value theorem. So let me move into that. Actually, transfer function, if I, so suppose I'm drawing a block. Okay, I'm drawing a block and it's like this. Suppose this is RS, this is GS, okay, and this is my CS, okay. So what I can write, transfer function GS equal to CS upon RS, right? This is the my value, and time domain, you know. So this thing what I have written is in S domain. It is in S domain, okay. Now, next, I'm talking about initial value theorem and final value theorem. So, initial value theorem. This is my topic. So, in short, I call it as IVT. It's important, you require it. So, in this particular theorem, what you have to notice that you have to take a limit that I'm writing. It's just like mathematics part, limit of ft, okay, and you have to mention the range of t, that is t tend to 0, okay, that will be equal to limit. Here again we have to take the, I mean ft is in t domain, right? So we have to take it in the S domain. So when we write it the same equation S domain, it will be 10 to infinity, okay, and here it's SFS. So this is a particular theorem. You don't need to prove the theorem or something. You just have to memorize that, yes, if we are talking about initial value theorem, or if any place we have to apply this theorem, then this is the equation. This is the equation, how we can apply it, okay. So limit of ft t tend to 0, that is limit of SFS or S tend to infinity, okay. This is my initial value theorem. Next comes final value theorem. What will happen in final value theorem? See here, the limit of ft, what we are telling, and here we have to write t tend to infinity, okay, that is equal to, again we have to write in S domain, this is S tend to 0, and you will write here SFS, okay. So these are the two very important. This is FVT and IVT, very important theorem. Some applications of this theorem we can get in later on some problems, okay. I will make you do some problems on this, then it will be much more clear to you. One note you should remember or write somewhere, that if roots of the system lies on the imaginary axis, then FVT cannot be applied. So the note is very important. Let me write here, because this is the limitations of FVT. What I told you, if roots of any system, okay, roots of the system lies on imaginary axis, then FVT cannot be applied. Okay, so this is the fact. And this is important because sometimes what happens, you will get to see this kind of problems where you can think that what I will apply, FVT or IVT. Okay, in particular that case, this note is very important. Okay. Okay, so we can do some problems now. Just a minute on this FVT and IVT. Wait. What is visible, my whiteboard or my notes? Can you tell me?
Whiteboard, ma'am.
Whiteboard. Okay, then write a question. Write a question. I'm going to the next page. Okay, the question you will just write down. Number one question: if Fs is it will be like this: S plus 2, S plus 3, and this will be S plus 5, S plus 6. This is my question. Find IVT and FVT in given function. Take down the question. Find IVT and FVT in the given function. So can you do it? Can you do this problem? Very easy. Do it and tell me. FVT, what is the output? In FVT you see, or in IVT, whatever. In IVT, in my output, you have S tend to infinity, right? And in FVT, you have your limit S tends to 0. So let us do first the FVT part. So in FVT, we know in my output, my S tend to 0. So putting S equal to 0, definitely you have to put S equal to 0. Then what will be the function? F is equal to how much? 2, 3, correct? Am I doing correct? Or what? 1 by 5.
Yes, ma'am.
Okay, so this
Yes, ma'am.
and in case of IVT, what do you have to put? You have to put S equals to infinity, right? So if you put F equal to infinity, then definitely my Fs will be 1. Okay. So this is the way how we can solve the problem in case of applying the theorem. Sometimes short questions actually come on basis of this FVT and IVT. Okay. Okay. Now I'll give you a model and you have to find the transfer function of that particular model. Let me show you the model. This is a resistance. Here another resistance will be here. Okay. And here will be a capacitor, R1, R2, this is my C. This is the way, and here you have to also give a output V0 और यहाँ पे होगा E input. Okay, so this is my circuit, and now what you will do, you have to just, this is my VI, keep it at VI. This is the model. You have to find the transfer function of this particular model. Obviously, transfer function का मतलब ये होता है, you have to find the equation in T domain. You have to apply KVL, and then you have to convert it into S domain, right? So can you do it? First, you have to apply KVL here. Apply KVL and tell me what is the answer. First, you apply KVL and then tell me. You apply KVL to the loop, okay? To the loop and just tell me what will be the answer. Have you applied KVL? Acha, one more thing which I forget to tell you. Current IT is flowing, okay? IT is flowing, current IT is flowing through I1 and R2 both, okay? So you must be required these two things. You will be having two equations, right? For VIT and V0T. So tell me the equation. See, you
Ma'am, VI equal to IRT.
okay. Okay, see, I'm writing the equation, applying KVL, you just check it out. Minus, dekho, you have to apply na some concepts of circuit theory here. So it's better if you have not learned circuit theory nicely, go through it once, kuch problems karo uska, then it will be much clear to you. The concept and the rules which we follow in circuit theory. Okay, because when you're applying KVL, that means it's completely depending upon the rules and regulations we use in circuit theory. Okay, so this is my equation for somehow for VIT. Now V0T, I'm doing it later on. Let me first do with VIT. Now I will apply Laplace in this. This is my equation 1. So I will apply Laplace in this particular equation. Okay. So if I apply Laplace in this equation, assuming initial conditions to be 0, then what we can write? IS R1 plus IS R2 plus 1 by CS IS. Okay. That is equal to VIS. I hope this is clear to you all how I'm doing. So from here, you can find out VIS. That will be simply IS, okay, multiplied by, here you will get SC, that is R1 plus R2, okay, and here plus 1, and down CS. So this is the thing. And for V0T, if I tell you, that will be very simple. That is IT R2, okay, plus 1 upon C, and here it is IT dt. And V0 in terms of Laplace, if I write, that will be I CS, okay, in bracket, you take it as R2 plus 1, R2 plus 1 like this. Now, if I tell you to write the transfer function of this particular equation, how you will do? TF is equal to V0S.
Hello.
Yes, bolo.
मैम यहाँ पर आप प्लस वी आई लिखें इक्वेशन 1 में, वहाँ इक्वल्स टू होगा ना?
हाँ. एक मिनट. Wait. अच्छा, you're talking about this portion?
एक्चुअली मैम वो इक्वल टू लास्ट में 0 था, वो दिख नहीं रहा था, वो इसलिए हम बोले.
Yes. ठीक है. Okay, so this is VIS, and as you know V0S and VIS, so you can model it. You can write the value. This is CS R2 plus 1. Okay, and नीचे लिख सकते हो CS R1 plus R2 plus 1. So these are the thing how we do it. Actually question कैसे आएगा बोलो तो, you will be given this model. जो model मैंने बनाया है यहाँ पे circuit का, ये model in the question they will provide you. Okay, and you will be asked to find the transfer function of this particular model. Questions come like this. ओके सो ये तो बहुत सिंपल एक मॉडल है जिसपे हमने KVL अप्लाई किया है एंड वी आर जस्ट फाइंड ऑन द टू इक्वेशंस एंड वी हैव जस्ट convert it into T domain to S domain and we have just find the transfer function. Short questions बोलो या फिर long questions बोलो, दोनों में यही होता है. They will give you the model and then they will tell you short question में क्या होगा. You will be given 4 options. Out of that you have to find out which is the correct transfer function. Okay, but solving process is same for both the cases. Okay, whether it's short question, whether it's long question. तो solve दोनों में ही करना पड़ेगा. Without solving this particular models, you can't find out the correct answer. Okay, that is the thing. So this is the total modeling structure, everything. Okay. Next, let me tell you, give you other. This is what we have done. We have, I have given you a model, and we have find out the transfer function. Next, let me tell you the thing that is, I'll give you an equation. So I'm writing here a system having input x, and output y. Okay, output y is dy upon dt plus 3y, that is equal to dx upon dt plus 2x. This is my equation. Now I'm writing here, find the transfer function. Okay. So from this particular equation also you can find out transfer function. So what you have to do, your first step is just the conversion from T domain to S domain. If this whole equation, you have to take first the Laplace of this whole equation. Okay, that will be the first step. So if we take Laplace of this particular equation, then what we can write? Sys plus 3ys, right? 3ys, that will be equal to x, sx, write this, okay, plus 2x's. Am I clear? I think थोड़ा clear हो जाएगा. ठीक है? Again, same condition you will apply here also, that the initial conditions has to be 0. So you first take common from here. What I can see, you can take common. अगर यहाँ से common लेते हैं, then I can get ys. If I take common, so I will get s plus 3. Okay, and from this portion, if I x as common लेते हैं, then I can get 2 plus s. Correct? So ys by x's, how much it will come? Ys by x's will come 2 plus, I mean s plus 2 or whatever. Achha, right here, you have to follow the same denotation. Okay, it is s plus 2. Okay, so s plus 2 upon s plus 3. Like this it will come. Like this it will come. So if now transfer function, as I told you, it will be just very simple. Gf equal to ys by x's. Okay, that is s plus 2 upon s plus 3. So this is my answer. Okay, output by input. Okay, so this is the way how we can solve it. I hope this much thing is clear to you all. Any question, any doubt, you can ask. These are very basic things. Okay, later on we will do some hard problems, some medium problems. These are very simple and basic problems to make you understand how from the model we can find out transfer function, again from an equation also. Okay, so our main motto, if we see a model or a equation, after first and foremost thing is that we